तो सरफेस टेंशन जो है पहली बात तो सिर्फ लिक्विड्स का फिनोमिनन है. ऑब्वियस है गैसेस डू नॉट हैव अ फ्री सरफेस. If you put a gas into a bottle, then whole of the volume is occupied by the gas. But in case of liquids, it is not that the case. In liquid, if the bottle is half filled, then liquid would fill the bottle up to half only. So liquids have a surface, a boundary which separates liquid and the surrounding air. That boundary, that surface has this phenomenon of surface tension. So, do you know cohesive and adhesive forces? Within a liquid, all other molecules are attracting this molecule. This way, this way, this way. All sides. If a molecule is present near to the surface, then forces in downward direction are more, but on upper side number of molecules is smaller. So upward force is smaller, downward force is larger. That means whereas all these vectors cancel out, but these vectors would produce a downward resultant. If a molecule is just at the surface, in that case the forces due to cohesion, that is molecules of same nature, water versus water, then these forces are acting only in downward direction, no upward force. So the force would become still larger. Zero force, larger force. On the surface the force is largest. So if you bring more and more molecules to the surface of the liquid, more and more molecules to the surface of the liquid, you will have to move against these forces. Like there is force of gravity. If you bring a suitcase or luggage upstairs, you have to do some work against force of gravity. So now inside the liquid there is force of cohesion against which you have to bring the molecule, bring the particle from interior to the surface. So as you increase the surface of the liquid, you have to perform more work, and there was theorem, work energy equivalence theorem. More work done means more surface energy of the liquid. And every process in the universe, every process will always proceed by itself towards a direction so as to reduce its energy. Like this pen tends to fall down because its potential energy is here larger. At a lower point potential energy is smaller. So it can reduce its energy by coming down. Whereas an air bubble inside water tries to go up because its potential energy is larger here and would become smaller here. Because by default lower density should be on the upper side, higher density should be on the lower side. But now you have made it in the reverse direction. Water is up, air is down. So potential energy is more. If water comes down, air goes up, potential energy is small. So bubbles have to rise up. So every process proceeds in a direction so as to reduce the energy of the system. So liquids also, if more molecules on the surface, more surface area, then liquid possesses more energy. So liquids try to reduce their surface energy. As a result, they try to shrink, they try to reduce their surface area. Among the given shapes for a fixed volume, like when you roll a chapati, earlier you have a ball of dough, then it is rolled into a chapati. Which one has larger area? Chapati. Least area is of a sphere, always. So liquids also try to reduce their surface area. That means they try to acquire shape of sphere. That is why raindrops are and there may be some point, some region in the air column where temperature is too small that the drops may freeze into hails. Hails are also spherical in size, spherical in shape. Otherwise, have you ever expected that you can receive ice cubes? Ice cubes can't come. There is no tray there. It was spherical in shape. It has frozen into the same shape. So hails are again spherical in shape. Clear? And when you wash your hair, when hair are wet, they stick together because this way area is more. As you stand this way, area is more. You want more air to pass, you increase your surface area in summers, but in winters you reduce your area. This way, this way, this way, this way, and this way. Isn't it?
Yes, sir.
So when you make the objects stick together, area is smaller. So here would start sticking together. Shaving brush, paint brush. When you put the brush into water, the hair come out, and as you take it out, they stick together in order to have minimum surface area of the liquid. So liquids try to possess a minimum surface area. Even a balloon also. Balloon tends to reduce its surface area, and in that process the surface of the balloon is stretched, is tight, and there is a force along the surface of the balloon. Same way liquids try to reduce their surface area. So a tension exists along the surface of the liquid, which we call as surface tension. Clear? So if I ask what's the direction of the tension on the surface of balloon, it is along the tangent, this way, this way. Same way on surface of water, you have a force of tension this way. We can imagine a line here drawn here. Forces are this way as well as forces are this way along the surface of the liquid. So to define surface tension is a force acting along the surface of the liquid or tangentially to the surface of a liquid, which tries to reduce its surface area, or in tendency to minimize their surface area. Liquids, gases nahi, only liquids, they have a tension on their surface, along the surface, which we call as surface tension. Definition is clear? So surface tension is a tangential force. Surface tension is a tangential force along the surface of a liquid that arises due to its tendency to occupy minimum surface area. Due to its tendency to occupy minimum surface area. Any doubt up to here? Now, what is its measure? How much is it? For that, symbol could be sigma. Some books symbol used is S. Some books use symbol T. All are same. So it is equal to, suppose we have an imaginary line along the surface of the liquid, or you may put a real line. You can put a matchstick which is floating on water. It is being pulled this way. It is also being pulled this way. Of course, net force is zero. Like you have a rope and you have a weight here. Net force is zero. But a force exists all along the rope called tension. Here we have surface tension. It exists all over the surface of the liquid, but both ways. So net effect is zero. So if I take the forces only this way, and I measure how much force is experienced in this direction on 1 centimeter of length or 1 meter of length, that would be measurement of how much the surface tension is. So surface tension is defined as mathematically force experienced, of course tangential force experienced per unit length on 1 meter of length or 1 centimeter of length. SI unit of force is Newton, SI unit of length is meter, so it may be measured in Newton per meter, or CGS unit is dyne per centimeter. Because surface tension is not much large, so usually CGS unit is applied, dyne per centimeter. And what are the expected dimensions?
20 minus 2.
Force MLT minus 2 divided by length, LL cancels, MT minus 2. And we may define surface tension because it has some relation with surface energy of the liquid. You can define it another way in terms of surface energy. For that, let us consider a U-shaped wire. Wire bent to U-shape, and we have a sliding arrangement, another wire with 2 loops on either side. Now place this enclosure, closed path, into a soap solution, shampoo. As you take it out, you would find a soap film in this region, like the toy with the game you enjoyed in your childhood. You know this?
Yes,
There was a small container having soap inside, and you have blown air into it, making bubbles. So this was a circular shaped object. Now we have a U-shaped plus straight line. Okay, so a soap film is developed. So since I told you that surface tension is force on unit length, 1 centimeter of length. Let us say length of this wire is L. So soap film has got 2 surfaces. A surface on your side, liquid, air. On my side there is another surface, liquid, again air. So because surface tension is a phenomenon of surface only, so soap film has got 2 surfaces, 1, 2. So surface tension is going to act on each side. So if length is L, force by length is surface tension, that means force in upward direction due to surface tension is F acting up divided by length on which it is acting. Length is L on your side and L on that side also. So total length on which the force is acting is 2L, equal to surface tension according to this relation. T is equal to force experienced by length. So that means upward force would be F equal to T into 2L. And out of here, we are going to relate surface tension with surface energy. Now let us pull this wire downward by a distance x. So this sliding arrangement reaches here. So this is a new portion of the film which has been developed now. Film had already some area, this much. On pulling down, this dotted portion represents increase in area. So since area has been increased, you have brought more molecules to the surface of the liquid. That means you have performed some force experienced in upward direction is F. You have to apply same force in downward direction, F. displacement covered is equal to x, force into displacement is equal to work done, and you have cos of some angle here and cos of 0 degree because force applied by you, displacement they are in same direction, cos 0 is 1 and force applied must be t into 2l into x. So what is 2l into x? Area, which we must write as increase in area. This dotted area rectangle is L into x, this side, and same L into x is on this side also. So area is increased on both sides. So we must write T into increase in area equal to work done, and work done according to work energy equivalence theorem is equal to increase in energy. So by performing this work, by pulling this wire by distance x, you have increased area by an amount equal delta A, and in which this additional energy is stored. So this energy belongs to only this newly generated area, and this is how much new area is. So if I divide energy, surface energy of the new area, divide by new area, then you get surface tension. That means surface tension also equals surface energy per unit area. So surface energy per unit area is also defined as surface tension. So units as per SI system, energy in joule, area in meter square, so joule per meter square. CGS unit, energy in arc per centimeter square. Dimensions, energy dimensions, ml to T minus 2, divide by area, again mt minus 2. So we can define surface tension in two ways. One is tangential force acting per unit length of the surface. Another is surface energy of the liquid per unit area. So there are two definitions, and another formula which is useful, since change in energy was equal to work done. So there are sometimes questions like a soap bubble was of 3 centimeter radius. You want to increase it to a radius of 5 centimeter. How much work is required? So surface tension into increase in area is equal to work done. But be careful when we discuss area of a soap bubble. Again, it has got two sides, outer and inner. Area of a sphere is 4 pi r square. But when you discuss area of a soap bubble, then area is 8 pi r square. 4 pi r square out, 4 pi r square in. So total area is 8 pi r square. So you may write 8 pi r new r square minus 8 pi old radius square, bracket closed, change in area into surface tension equal to work done. Important formula for numericals. This is another formula for numericals. Surface energy per unit area or force experience per unit length.